Everyone, so I have the talk I was planning to give until Thursday, and then which is going to be the first 5 minutes of this, and then the talk I decided to give after talking to my students on Thursday and noticing a problem with language models. So I wanted to get your opinion about and see if you think that the solution I'm going to propose is a good solution. So the talk I was originally going to give was about our paper called A Pre-Trainer's Guide to Training Data, where we measured the effects of changing a bunch of things in the pre-training data, such as what year or month the common crawl scrape was from, that's data age, the domain coverage. So in this case, we used the pile and systematically removed different domains of the pile and then observed how this impacted downstream performance after we pre-trained on that subset of the pile. And finally, taking both C4 and the pile and doing quality and toxicity filtering on them. And so because I've truncated this part of my talk to 5 minutes, I'm not going to talk about methods at all. I'm just going to give highlights of the answers to these 3 questions here. And so a lot of this should not be surprising, because I think lots of the presentations today have been alluding to similar trends to the ones I'm going to be talking about briefly. So first of all, can old pre-training data cause performance degradation? The answer to this is yes. If you look at the x-axis here, it's the difference in year between when the scrape of the common crawl we took, so that's the pre-train year, and then when the evaluation data came out. And you can see that as the discrepancy between when your pre-training data was collected and when the evaluation data was collected grows, you get worse performance, which shouldn't be too surprising, but it does mean that papers that compare models trained on very different years on the same evaluation task, they might be evaluating differences in model performance, but they might actually be evaluating, well, just there was better temporal alignment between one of the models and a different model. This is especially true. There's still a lot of people using like fairly old models like T5 that was trained on 2019 data. So this is becoming more of a problem as we speak, so long as we still have old models that are widely used as baselines. The second question we asked in the paper is, what is the effect of filtering out toxic or low quality training data? The brief result from this that I want to highlight is there is a trade-off here. So on the x-axis is the ability of the model to generate toxic text. Generally, we don't want models to generate toxic text. On the y-axis is the ability of the model to, after fine-tuning, label text as toxic or not. And so it turns out, and this shouldn't be too surprising, but if you filter out a lot of toxic text from the pre-training, you get a model that's very unlikely to generate toxic text. That's good, but it's also really bad, even after fine-tuning, at classifying text as toxic or not. And so whether or not you should do toxicity filtering, and the amount of toxicity filtering you should do is really dependent on who you think your downstream users are and what tasks they're actually going to use the models for. So based on like results like this, I kind of don't like the phrasing general purpose language model, because I don't think there exists a general purpose model. All of our models are going to have some trade-offs. This is an easy one to measure on a plot, but some trade-offs that make them better for some users and worse for other users. And an interesting result here is this inverse filter. So in this case, we deleted the least toxic part of the data. And you can see that this makes the model even more toxic and even better at identifying toxic text. That was kind of interesting. The third question we asked in this paper is the domain composition question. And it's very hard to sum up these findings with one conclusion. Some things are not too surprising. For example, if you remove academic data sets from the pile, you get a model that's worse at answering academic questions. No, so actually get a model that's better at answering academic questions. Those are the surprising results. And some of the others, I don't know if these are surprising or not, but things like removing PubMed, you get worse at common sense reasoning. So I really don't know how to interpret these results. I think there's a lot more room for studying the effect of domain distribution, and a lot of the open weight but not open source models have if we're lucky, they have a table in them that tells you what percentage of the data was code versus books, etc. But it's very expensive to do actual ablations on this and see what is the ideal percentage for the tasks that we want our model to be able to support. I think this is a very fruitful area for more research. So, this was like how much worse a model did on data, with this data set removed compared to when that data set was in the pre-training data.
Sorry, can you say about tokens or model parameters?
Oh, all of our experiments were on 1.5 billion parameter models. So that's another big question. We trained like probably 60 or 70 models for this paper, each of them 1.5 billion parameters. This was extraordinarily expensive. This was Shane Longpre and intern at Google's project. I don't know if the conclusions we're drawing here would hold for 50 or 12 billion parameter models or larger ones. That's another question, but I don't know the answer to. We did also run experiments on smaller models, and generally the experiments on the smaller models agreed with the 1.5 billion parameter model. Okay, so that's like what Shane would give us an hour talk in 5 minutes. But I'm happy to answer questions later. The other thing that I was talking with my students about on Thursday, but I decided to be more interesting to discuss at length today, is the fact that there's no one-size-fits-all alignments. I've already sort of alluded to this in saying that I don't think there exists a general purpose model. And I don't think that there exists a singularly aligned model either. But first, before talking about that, I just want to like go over what is alignment, because different companies offer slightly different definitions. So like IBM says it's the encoding human values and goals into large language models to make them helpful, safe, and reliable as possible. OpenAI says it's a model that can, this is one of its original definitions of alignment. It has other definitions since then, but a model that can safely perform the language tasks that the user wants. Or if you ask Anthropic, it's helpful, honest, and harmless. What is alignment in practice are these two steps of training. So you have your pre-trained model, you do some sort of instruction tuning to make it good at following instructions, and then you do some sort of usually reinforcement learning type thing so that its generations would have a high reward according to a model trained on human preferences. But what we are promised by alignment, so this is the main point I want to say, is not necessarily come to fruition. So here are some of the things that I think, looking at all of these blog posts from the companies, that they promise when they talk about alignments. So aligned models are supposed to be helpful. They're supposed to be multitask learners that can generalize to many applications. I use the word average for the second point, but that's not a word that most of the companies use, but I think they intend this, is that the large language models that are aligned should be accessible to average users. You shouldn't need a lot of skill to get it to do a particular task. You should be able to just tell it to do a task and it does it. And also aligned models should retain the capabilities and knowledge of the pre-trained model. So maybe you're masking some of those capabilities. You don't want the model to like give instructions on how to build a bomb anymore. But we're not trying to like remove from the weights those capabilities. We want the model to be able to do a superset of what it could do before alignment. And so here are some of the examples I came up with my students on Thursday that motivated me to write this talk. So here is the prompt, output a fruit chosen completely at random. And here are 3 models that claim to be aligned or instruction tuned in some way. You can see that Llama, which is on the left, says, okay, here is a random fruit, and then gives me the fruit name. Mistral just gives me the fruit name. And Gemma gives me code to pick a random fruit from a list. And so all of these are correct answers. Like if I independently saw one of these answers and I was asked, is this an appropriate answer for this prompt? I would probably say, yes, this is an appropriate answer. Let's look at another one. This is, I just took a random multiple choice question from MLU, and you can see that on the left, Llama answers, despite me saying, answer with the letter corresponding to the correct answer, nothing else. Llama says D, all of the above. Mistral follows my instruction and just answers with D. Gemma answers with the answer is D and then tries to explain why the answer is D. So I would probably say all of these are correct again. They all correctly say that D is the answer. Here's another one. I ask, hey, have you visited New York City? And Llama says, sorry, I don't have personal experiences or memories. Mistral says yes, and Gemma says yes, but Mistral asks me if I want more information. Gemma assumes I want more information and generates this whole list of things I should do in New York City. These are all, again, correct answers by some definition of correct. And finally, I ask, what's the name for a syndrome where someone thinks there are little people living in traffic lights making the colors change? For this one, again, this one is particularly interesting because Llama tells me that there is no such recognized medical or psychological condition. So it's telling me this doesn't exist. Mistral just rolls with it and makes up a name for this syndrome. It calls it traffic light phantom syndrome. So if I was like a creative writer wanting to use these models to help me write stories, the second answer is definitely the best. If I'm seeking medical advice, maybe the first answer is the best, or actually the third answer by Gemma, which actually comes up with a real disease that exists that kind of makes sense. So apparently there's something called pareidolia, which is a perceptual phenomenon that involves seeing faces or meaningful patterns in random objects. I didn't know that exists, but that's legit. That kind of seems vaguely correct. Yeah. So my point here, and I know you guys have all looked at tons and tons of model generations, is that every single generation I have showed you is correct in the generic sense, but for any particular user, it might not be correct. And this is why I argue that despite what we are promised by alignment, open weight language models don't live up to these promises because we assume that there's this single generic entity we are aligning for rather than thinking about what particular users we want to align for and can we make models easily controllable for specific sets of users that we want to target. And so I put on my first slide about the promises of alignment, aligned language models are supposed to be helpful and multitask learners, but it turns out helpful is very user and task dependent. I put that language models should be accessible to average users, but you've all have seen that you still have to do a ton of prompt hacking to get language models to output things in the format you want them to. And if the goal of the downstream user is just to use the language model as a chatbot, most language models, the aligned language models work pretty well for that. Like I could parse out the answer D from the answers to the multiple choice question as like a human. But if I had to write a regex that worked for the outputs of all of those models, that would get a lot more complicated. And so if we want the output of the language model to be processed in any way so that it can be built into a larger application, we still need to do a lot of prompt hacking, is my experience. And for this last point, the aligned language models should retain the capabilities and knowledge of the pre-trained model. I didn't show any examples of this, but there are tasks that aligned language models are just worse at than pre-trained models. For example, doing alignment tends to reduce the entropy of the distribution outputted by the model. So if there's tasks where you really value randomness, you're going to get more randomness out of the pre-trained model than the aligned model. Or if you do want a two continuation, suppose I'm a creative writer and I want the model to suggest an end to my sentence. Pre-trained models are actually much better at continuation, as you might expect, than aligned models. And I've worked at Google for many years, and one of the things in the Google mission statement is like all of the people you should respect the opportunity, respect the user, etc. So I'm sorry for using Google lingo here, but I don't feel like at least the open weight language models I've played around with actually really respect their users. Language models and their creators make assumptions about what the users want to see in generations rather than asking them what they want to see. And users have only a few options for changing up the generation behavior. So if I'm playing around with a language model and I'm not getting the kinds of outputs I want or the format of outputs I want, what can I do to fix that? Well, I can do prompt hacking, which, as we all know, is kind of painful. And if you're not an expert in prompt hacking, you might just not be able to figure out the right way to phrase your task. You can fine tune, which is great if you have data to fine tune on, but it's also complex and expensive. Then you have another set of model weights to deal with. You can also do what my students have been doing, which is switch to a different model. Like see, okay, this thing that I want to show doesn't work on Gemma. Let me try Llama instead and see if it works on Llama, which I think a lot of people do. And I have been in NLP since about 2017, which is not as long as a lot of people in the room, but I feel like when I joined NLP, there was actually a lot more talk about controllability than there is now. And like being able to condition on like ways you want the generated text to look and get generated text that looks that way. And if you all who are in the field longer than me want to disagree with that, you should say so when we get to the question and answer part. Just as like a few examples of papers that I put in here is like, there was the CTRL paper from Salesforce, which was trained on Reddit. And they had these control codes, which were indicative of the subreddit that the pre-training data came from, which meant in inference time, you could be like prompt of a knife and the control code horror versus a knife and the control code reviews and get very different generations. Or like there was a lot of work on like generating text at different levels of simplicity, like generating text at a 5th grade reading level versus a 12th grade reading level, etc. That's what's on the right here. And on the left, this was a paper that tried to generate dialogue outputs that met some set of attributes which were specified. So you could specify whether you wanted the response to be short or long, low or high specificity, the amount of relatedness to the input, etc. And so these are techniques that we were using for a while in the field, but then we realized, wow, you can just control language models by putting things in the prompts. I feel like we moved all the way in the direction of specifying everything in natural language. And I wonder if we should move a little bit back towards the direction of allowing useful controllability signals to be specified in ways that are not natural language. So that's what I'm curious to get all of your perspectives on. And so my proposal is maybe we should be considering building large language models which users can control without prompt engineering, fine-tuning, or switching up models. And some of the aspects that I put here are whether the generation contains code. Like maybe I should just be able to specify wherever I want code in the outputs. Or like whether I like the level of conversationalness I want. Do I want it just to save a letter, or do I want it to like give an explanation? Things like writing style, like brevity, formality, etc. Timestamp, like do I want it to generate text as if my prompt was given in 1950 versus 2022? If I say there was a deadly pandemic named, should it respond to COVID or should it respond with make up something? I don't know. The imaginativeness. So I've done a lot of work with creative writers, and this is one of the #1 issues I have with today's language models is GPT-4, GPT-3, to go to the closed source examples, are less creative in many writers' minds than GPT-2. Because it turns out that models that are less trained are more likely just to say random weird stuff. And GPT-4 is very unwilling to say random weird stuff. And that maybe that should be something that is like easier to control. And I'm sure, but this is like, there's many other things that we could put on this list. I do have some caveats though, but I would like to mention is if we choose that adding these sorts of control signals is valuable, there is a slippery slope, I think, towards unethical data collection practices, because this might mean that we need to collect more data that is labeled with these sorts of control codes or information, and have models that are more customized to individual, like have training data that is more customized to individual users, and maybe there's some privacy violations or something there. I haven't really thought through this much yet, but I wanted to put it on here. We also need to figure out which controls would be most impactful. Like, I don't think all of us sitting in this room should be the ones who just like arbitrarily pick the most impactful control codes. Like, I would like to actually survey who are most of the users of open source language models. What are they doing with these models? And what would be actually like impactful control codes to have? And finally, I just like came up with talking about this, and Thursday while talking with my PhD students. I don't know if this is a real problem. I would like to find out if there exist users who would prefer these sorts of toggles I'm proposing to just like prompt hacking or the other solutions that already exist. And then I had another slide here that disappeared that I just mentioned. I think that these would, from at least the ones I have on the slide here, would be fairly easy to implement. And there's already like precedent for some of this. Like, I really like the recent Cohere model that does tool use, because you can just specify what you want your generations to have by what tools are accessible to the model. So I think that's like a very cool thing that's in this direction, the spirit of this. Anyway, curious to get all your thoughts.